Greetings, everyone. Welcome to Back to Basics. What we are looking at now, I want us just to briefly looking at what are these, or rather, what are our chain isomers, right? So now, firstly, I think this word chain isomer basically it literally just means that now these are going to be molecules, right? So these are going to be molecules with molecules with the same. So these ones are going to be with the same molecular formula, right? Molecular formula. But now this is going to be uh different in what? This is going to be now different in terms of what in the type of chain. Okay, different in type of chain. I know that you are probably wondering in terms of what is this have to have to do with this, or rather what does this mean. Now let me just give you a brief example. Now, for an example, let's say I give you this, right? Now, let's say I give you these particular structures, right? Let's say I give you that you are having this, your structure here. This is your structure. This is going to be this particular structure of ours, right? Now, then this is going to be what? Your butane. Let's say you are having your butane. This is going to be our butane. Now, I want us to look at what is going to be another structural formula that is equivalent or that is the same with butane, right? Now, butane, remember, it is given by what? This is going to be your butane. And if this is your butane now, this is going to be given by what? The formula for this is going to be C4H what? H10, right? Now, which means now, what else? Do you have any other structure that is almost going to be the same as this, right? But now there's going to be different type of chain. For an example, if let's say I give you that now you are having your methyl propane. Let's say I give you that you have your methyl propane. I want you to take something here, right? This is your methyl propane. Now, in this particular methyl propane, I want you to check in terms of what is the arrangement in here, right? Or rather, how is the arrangement of your carbon and also your hydrogen, right? Now, surely this, now if you can write in terms of what is going to be your general formula for this, right? Now, this is also going to be written in terms of what? This is also going to be 1, 2, 3 carbon. You are going to have 4 carbons also here, and you are also going to have 10 hydrogen. So basically what happened is that now the arrangement of your butane, can you see that your arrangement of your butane now have also changed now, right? The type of chain have also changed, but now what have been changed? It is what? It is the molecular formula. Can you see that the molecular formula of this is still going to be same as C4H10? Why is this C4? Because you're having 1, 2, 3, 4 carbons here, and you're also going to have you're going to have 10 hydrogen around. Okay. So basically, this is going to be the concept of your what? Of your chain isomers, which means now this the molecular formula doesn't change, but the arrangement of the structure of these particular molecular it going to what? It changes, right? Now I want us to also look at another example that is almost the same as this. Now let's say I give you this, right? Now let's just make up our space here. Let's say I give you these other examples now, which I want you to take a look of, right? Now let's say now I give you that you are having your pentane, right? Now if you can look at your pentane, let's say you are having your pentane, this is going to be your pentane. Remember, what does pentane mean? Pens means what? This means 5, right? So this is going to be this is going to be 5 carbon. The ane at the end, it represents what? It represents your alkanes, right? Now, what else? Let's say I also give you what? Your 2 methyl. Let's say I give you your 2 methyl, right? Let's say this is 2 methyl, this is Y, then your L, and then methyl uh butane. Let's say I give you a 2-methyl butane, and also I give you the last one, which is going to be what? Which is going to be 2 point what? 2.2 dimethyl, right? Dimethyl and what? This is 2.2 dimethyl propane. I want you to do what? I want you to look at the structures of these three formulas, right? Now let's start with the first one. Now your pentane is going to be given by 1, 2, 3, 4, 5, right? So this is going to be 5 carbons, right? And then obviously you're going to add your hydrogens here. You're going to obviously add your hydrogens here. As you can see, these are going to be your hydrogens, right? And now from here, what is it that you are going to take note of here? Now from here, if this is your pentane, right? Let's write the formula for this particular pentane. Now your pentane, the formula for pentane is going to be given by C5H what? This is going to be H12. Isn't it so? So basically, this is going to be the formula for your pentane, right? Now, let's say now we write the second structure that I gave you there, which is 2-methyl butane. So remember, how do you write the structure of this? This you're going to start with your what? You are going to start with your butane. So this is going to be 1, 2, 3, right? 3, 4 carbons, right? And this is going to be, then your methyl is going to be found in your second carbon, right? So which means this is basically going to be how you write your structure, your structural formula, right? So now, and now from here, what else now are you going to have? I want us after here to look at what is going to be now your what? I want you to look at the chain here. Now, if you can check here, can you see that the arrangement of the chains are different, right? But now, if you can find out what is going to be the molecular formula, look, you're going to have 1, 2, 3, 4, 5 carbons, which means you're going to have 5 carbons. And now your hydrogens that you are going to have here, you are also going to have 12 hydrogens out here. So which means these are going to be your chain isomers, right? Now, if you can look at the arrangement of these branches, the arrangement of these branches are different, right? But the formula, can you see that the formula still remains the same? Out here. Now, I want us to look at the last one. Now, the last one is you are given that you are having what the last one is your propane. So this is going to be 1, 2, 3. Remember, prop means 3, right? So you're going to have your propane and dimethyl, 2.2 dimethyl, which means here you are going to have your methyl here, and you are also going to have your methyl here, right? So now, if let's say we draw these structures, right? Let's say we draw these structures. I want you to compare all of these, right? I want us to then come back and compare all these isomers and see in terms of what is it here? Now, surely you can see that the arrangement of these structures already is not the same, right? The arrangement of these structures is not going to be the same because look, we are still having 1, 2, 3, 4, 5 carbons, right? And now if you can calculate the number of what? Of hydrogens here, you are going to find out that the number of hydrogens again is going to be what? It's going to be 12, right? So basically we are saying now your structural, or rather your chain isomers, you are going to have the same molecular formula. As you can see, the molecular formula here is the same with the molecular formula here, and it's also the same with the molecular formula here. But the arrangement of these particular structures, they are different. Out get. So basically, this is what we mean when we are referring to our chain isomers. Out again. Now, hopefully, this makes sense to you. And thank you very much.